So what we're gonna do is we're gonna build a system right now and then try to metaphorically present the concept of software engineering and understand how softwares are complex and AI or any chat GPT or something, why it's it's time consuming, or it's not possible to develop softwares by that. Softwares are complex, error prone, have bugs, constantly need improvement. Today, what you see on Amazon.com or any other web software, mostly we have cloud. So Amazon is also a software, Amazon.com. That happen over a period of 25-30 years, right? In the same way any other software, Facebook, Instagram, or Microsoft Word or something. So building a software, this is for people or students who wants to understand, right? Now just imagine that and I'm doing this by a laptop and drawing. I don't have like a pen or something to draw some. I'm gonna do my best to draw it. So you're at home and you wanna make a smoothie, right? So here is your mixer, right? You have to promise that this is the only part where this will be a little bit time consuming, but from this we're going to jump to coding and all the parts, right? So what we're going to do is, these are your ingredients: banana, apple, whatever you are adding to your smoothie, right? I'm not going to draw it, they're just going to be like this. So you put this in here, right? And you get a glass of smoothie, right? This is your one glass. This is a perfect example of a function. It's a function taking a value of x, which are your ingredients, and it gives you an output, which is a glass of smoothie, right? Now the problem happens is this one glass makes so many consideration comes into part, right? For example, this glass makes you a minute, right? And what happens is that's fine, you're just one person, but what about you're making this for 5 people, 10 people, 15 people, n number of people, right? Those are the considerations that we do while writing algorithms. So you have people coming at 10, 15, you have a party or something. So what happens is that this one machine will take 10 minutes to make 10 glasses of smoothie, right? So what you do now, we want another glass, 2 minutes, another glass, 3 minutes. So you see the time is proportional to number of glasses, right? So it's kind of getting complicated already, this function. Previously this function was giving f of ingredients was equal to x1, one glass. Then it's now x1 comma x2 comma x3, 3 glasses. So it's going to take that much time. So what you do, you say, well, to minimize that, I might just add, right? I might just add another machine, right? You buy another machine, you buy another mixer, and it contributes to this output, and now you have more glasses in 1 minute. One is produced by this, one is produced by this. Now in 1 minute you have 2 glasses. So you increase your production resources to get, right? So this simple function, for now it's just a function. Now we go ahead, a friend, you guys are talking, and then suddenly somebody gives an idea that, what we can do, why don't we make a business out of it, right? So these are our ingredients. Banana, apple, whatever. Okay. So you say, well, that's a good idea. Why not? So you make a shop, right? You make a shop. So we're gonna draw a shop by this kind of grid, right? A kind of a slab or something. This is our shop, right? This is our shop. So buyers will come here. This is one buyer, another, and so on, right? And you are one person. So what happens is they place an order, and you take an order, you make them a glass. The problem is that it is now you have 2, 3, 4, 5 customers. It's taking time, so you just decide either to buy a bigger mixer, but then there is a problem. You buy a bigger mixer, what, you don't know how many customers are coming, so you cannot just make one glass in a bigger mixer. So you logically, I will think like, what, let's add another mixer, right? I added another mixer, and now this is also give me a glass of smoothie. The smoothie, I give it back, all of this smoothie, and then I give it to the customer, right? So we will do like this. But now somebody has to take the order, somebody has to work on this, work on the machines, right? So this is our alien friend that is working on the machine. One employee is enough. Now you see, it's very simple right now. This is our front end, what you see on different websites, right? This is our front end. You can imagine metaphorically, this is itself a complete module, a complete setup. You're not gonna just go ahead and make your own shop. You basically rent a shop. So somebody has already worked on this part for you. You didn't do it, right? Customers will come in. So this is good, but as time passes, we have more people coming in. People love your idea, people love this software and this and that. So more people are coming in, and you cannot meet the demand, right? There's lots of demand. Then that, as an owner, you start thinking that, this is increasing. So you start more machines, right? You add more machines because you want to scale. This is the concept of scaling in software. You add more machines, right? But scaling comes with a cost, which means now I need more people. So this person, right? So now they will operate on these machines, and now we have more glasses of smoothie. Now Customers are happy, the owner is happy, some revenue is happening. Here we will add more resources. You need more input resources, right? And things are good. Looks good so far, right? All of these resources goes, machine. But now this person, the owner, says, it's I cannot just take order and give it and this and that. So what he does is he steps aside, right? He steps aside in here to manage the business, right? In here he put these, I will put these people who are going to basically take an order. And then in here, let me change the color. In here, in here, I'll put another kind of external API, external software. I'm not gonna build this, right? You go to all these restaurants, you have the software that take your orders and stuff. So these people take the order on this machine, and then what they do is and then these people have this screen in here that shows all the orders. So from here things will come in here. You see some automation happen, some automation is done. A very simple business, think about it. And I hear a lot about this AI and all this kind of thing, generating all these things. Now, it's not, I'm not saying it's not possible, but it's so complicated. Software is automation, right? So what happens is, orders are happening. These people are looking into these screens, this screen, and once the order is ready, they give it back, and that order goes to the customer, right? You see, automation is happening now. Our first machine, let's just, I think I like this color. This is our software. Now, well, it looks good so far. Customers comes in, order taken, process, give it back. But yeah, a couple of customers are coming, and yes, people are happy, and customers are coming, and this software is also, our front end is good, right? I think I should have taken a bold line, yeah, right? The software is good, the owner is happy, everything's good, right? Now the owner says, well, no, it's not, we can scale, we have more demand, I can expand the business, right? The business can be more expanded, why not, right? So we cannot just keep adding in this scenario. I can think about another thing that, there's lots of waiting time at the front. People come in, they queue, they take an order, blah blah blah. So now instead of this, what they do is, what we're gonna do is we're gonna add another layer as well. Another layer here. This is an application, online application. Now buyers can go here, sellers, buyers, yeah. And also they can put an order from anywhere. Here the buyer is directly to the app, and then this automatically comes in here, right? And then it goes to this part, right? Now the queue is less. Not everybody just queues in here. In advance, these order will come to these employees, and they were going to create, and they put it, and then once the person comes in, they see They give them the order just like in Starbucks in another place, right? Good. You see, 1, 2, 3, 4. Already we have used 4 external APIs in here, already, in a very simple system, right? Now, good. All is working. There is a little bit scaling done. So a lot of things can happen. These machines cannot function. Machines have less power, this and that. We can replace the machine. We can have better quality machines. Everything is going to cost us. The more scalability, the more cost. These are going to keep increasing. Ingredients are going to keep increasing. Ingredients are going to keep increasing. More ingredients you need. Cost is increasing. You see what's going on? So good. That's fine. And then there's more demand. There's definitely more demand. And then what happens is that this online thing happened. Then we also put people in here that can specifically work on these orders, right? Good. All is good. So now the owner sees profit, the owner sees lots of input, the owner sees people liking it, blah blah blah. Then the owner says, well, what else can we do? How to optimize this further? I want to scale this thing, right? And forget about this thing, that these, in a metaphorical term, these are own resources. Everything is a resource within the business, apart from these external APIs or applications that we are using to facilitate our business, right? And these people are our objects within the business. The boundaries, whatever is happening, that's our software. That's our, metaphorically, you can think this business is our software. Okay, so all is good. Then what happens is the owner says, well, we want to scale further. Okay, so scale further. The owner has access to the data. All data is analyzed, and they see the demand. They see which types of smoothie people like, and this and that. They develop a process to, make the smoothie in advance, right? So it's up to the owner, the way the owner is designing. It's up to this person, right? And now what happens is that they say, well, this part, this is not organized properly, right? So it's going to be organized. Orders are coming from the front and the online. So they take the data, and the owner, this upgraded process, right? This upgraded process is taken. This upgraded process is taken and passed to the employees. They, in turn, will make the smoothie and store it somewhere. That's our database, right? They store it in here. Once the customer comes in, they give it back and return it to the customer. That's one storage facility, right? What else? They also know this is one facility where they can make an advance, and whoever comes in randomly, they pick up the smoothie, give it. They also know that there are frequent items, the frequent items people get, right? They have a caching layer. That's our caching. They also put certain products in here that people come in, they say, oh, I need strawberry smoothie or something. Boom, it's right here. Give it. We don't have to go to the storage. We don't have to go in here to make it, blah, blah, blah. That's good. So as the people, online orders are increasing, in-person orders are increasing, you need more people in here. You need to properly optimize this thing, right? So for now, pretty good. Everything is working. So now the owner says, well, this is in one location, and we can do something called parallel implementation, right? Parallelly, we can do this business somewhere else as well. So now they take this location and make another shop, the same process in here, the same process in here, the same process in this location, and the same process in this location. You see, multiprocessing, parallel implementation, same thing, same process is running here, 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 the whole thing. So now you can see how complex it is just building a simple smoothie application, simple smoothie shop, right? These, in computer terms, these processing units, these machines, you can consider them as your servers. These are, they get the request, they process it, right? These are, or a better terminology in here can be that anything across from when the order is received, the client, this is your client, this is you, makes a request. These people makes a request, and request is taken, all sort of authentication and everything is done, right? Here is a layer we have, these are the employees layer. See, comes to this layer, they input it here, making sure user authentication, everything is done, the user is valid, the user wants something, the user has payment method, this and that, and then only it goes in here, right? So then it comes within here, these are various functions. You can say within this server, this whole business, you can think from here, is your application bits and pieces that's running inside a server. A better approach will be, the server is your whole shop, and these bits and pieces are working with these within those shops, right? Smoothie, this is one of your module, one of your libraries that you have written, one of your design that you have done, right? You see, I'm making this coming up. It's not like I will know it all. I'm just trying to come up with something that can give us a better sense of the software approach, right? And then you have these workers. These are other modules, other functions in your architecture that's facilitating these ones, right? And then you have your products, the output of these functions. This is the JSON value that basically you send back to the client, to the front end, right? And this, and operations also happen on the database side. This is our caching layer, this is our database layer, right? We are saving stuff in here, right? These are functions. We multi-threading, multi-processing. One process, now you're running it on multiple threads so they can be processed at the same time, right? Ingredients are the inputs to the function. These ingredients are basically coming from this part, what the customer wants, blah blah blah, input. We in computer terminology, we don't really have exactly the bananas, apple or something. These are just string values, just imagine, right? And then we have these workers who are actually performing on these functions, some other functions that are calling these functions to do something. But you see, We have this layer, external applications, external some other APIs your team has written or something. Then we didn't even say that the payment mechanism here is also a payment gate, right? But also you see here we are not very optimized here. Who takes which order, right? Who will take which order? It's not like everybody just looks at the screen. So you see this routing mechanism that we have. When you go to the request comes in, it should go to which server, right? We have API gateway concept, we have other tools that can, load balancer is there, and all these kind of thing, right? So here also we need another layer. We need to put a load balancer, or we need to put some kind of a routing mechanism that can say you take this order, you take this order, you take this order. That's how it can be processed, right? So you see, I can replicate this in this location, in this location. You see, a simple shop, a simple smoothie place can have this much complexity involved, and then putting this in code and designing and architecturing is a massive job. This is the essence of software engineering and software craftsmanship, how good softwares are made. This is one function. Just like in real life, you can buy a machine for $10 and you can buy a machine for $100. So it's now on you what kind of function you are writing, a $100 function or a $5 function. Efficiency, scalability, and then as the time passes, the business people can then start thinking as where we can optimize, how we can speed up the process, right? So this is a whole cycle. At this moment also, you see, we started from very minimal. Now we have so many bits and pieces and these need management. This storage has to be somewhere, right? So this can be in the same server, this can be in the same different server, this can be in memory, this can be Redis cache or something. So this is a whole idea, metaphorically, for beginners to just get a gist, and also for people who wants to understand. But most importantly, software is a complicated process. Whoever tells you that, for example, now if we sit and we say, oh, let's just go ahead and start coding this software, it's going to take months. This is not just going to happen in one YouTube video. It's practically not possible. We have to, even if we code this function, this machine, this module, we have to think about it. What ingredients are coming? What's my output? What to do? What to check? Blah blah blah. You keep thinking. That's why softwares take time. So it's practically not possible to write. You can write one function in one setting, just a simple insertion sort or some other function, some graph algorithm, but not like a whole system. So building a whole end-to-end system, this is what's called end-to-end deployments. End-to-end system takes time, takes understanding, takes real interest in software engineering. So I hope this helps you understand the concept of software engineering. It's fascinating, it's amazing. It's so cool that you can practically tell computer that this is the system that I want to build. But it's not just writing lines of code and then you go ahead. It's complete architecture. It's understanding it, right? And a lot of other things will come in as well, as which I haven't. There are lots of bits and pieces that we can extend this thing. So I'm going to try to jump into other metaphors later on, but I just wanted that this will help everybody. Thank you so much. Have a good day.